This is a demonstration of the COMETTS simulation system that we have been able to add FSM and the ability to perform ground delay program training into the COMETTS application over the last couple of weeks since our previous discussion. I'm going to do a demonstration of the capability to connect FSM to our COMETTS simulation. I'm just using this one screen here, so it's going to be a little bit busy, but in an actual use case, these displays would be split over different screens. I have our COMETTS system, as we showed you at the previous demonstration, running. This is running the same scenario for DFW, and it includes the wind shift between around the 1600 hour that could cause the need to go to a northwest operation with just a lowered acceptance rate of 48 aircraft per hour. As the simulation begins, you see that we can still show the TBFMP GUI. We have the weather display showing the TAF and the METARs coming in, and the information that indicates the potential wind shift that will cause the need for a ground delay program to be considered. We can also still show TBFM, but in addition to those tools, we also have FSM. FSM has the ability to monitor DFW ADL data that is being generated from the COMETTS simulation. You can see, in fact, that on the monitored live that it just received its first ADL at 1305. We're playing the simulation here at 10 times normal speed, so at 1310 we'll get another updated ADL. This version of FSM is actually an older version. It's from about 2012. It's one that we were using for the GPSM work, but it should be consistent with the type of interaction that would be required for using a more current FSM. The FSM does not run in a browser, so this is something that would have to be considered, that the FSM display would need to be run on a workstation there, but it could connect to the rest of the simulation running in the cloud and connecting to the browser. You can see that we've received the ADL data, and the ADL data is continuing to update in FSM. We have different aspects of the FSM display that can be used and manipulated here in the scenario. When we receive the next ADL at 1320, what I'll do is I'll switch over and slow down the simulation to normal speed, so that for training purposes I am operating on the normal real-time operation. And what I'll do is I'll go into ground delay tools mode in FSM to be able to create the ground delay program that we want to be able to run. I'm going to run that between 1600 and 1759 based on the weather forecast. I know that the arrival rate may go down to 48 for the 1600 and 1700 hour, so I'm going to fill that in. I'm going to use a GDP distance of 1,000 nautical miles and then run that GDP. I get the power run results. You can see the results here showing the number of controlled flights, and By the way, I apologize, I'm not necessarily an FSM expert, so if there are any steps here that I'm doing incorrectly in terms of standard procedure, please forgive me for that. Based on having that plan, then I can run that to get the cover sheet. Select the program parameters, select the reason, and this would be for wind. And then we can send the GDP. And so the GDP now has been created and sent back to the simulation. So I can close these and then go back to our DFW view. And then when we get the next ADL, we should see the updated ground delay program. So I will fast forward again. And there's the next ADL that just came through, the 1325. You can see the flights that are controlled. You can see the time period of the GDP, the lowered rate. Interestingly, you can see that based on what I selected for the 1,000 nautical mile distance, it doesn't look like it was able to control all of the flights that would be expected. So the plan seems to go a little bit above the target of 48 flights during the 1600 hour. All of the standard FSM features are available because we're running the actual FSM here. But again, this scenario now is also running in COMETS and is actually executing on the EDCTs. So as we watch the scenario move forward, in fact, I'll go ahead and speed it up to 30 times so that we can watch the event actually unfold. We'll be able to watch and evaluate how the flights continue to take off according to their EDCTs and then fly to DFW. We're continuing to get updated ADLs in FSM as we go through the process. You can see the flights starting to take off and showing red as a status on the FSM display. And we're getting continued ADL updates at this rate of 30 times speed. As we get into the scenario further, we will see the wind shift start to approach, and we'll start to get the same types of interactions and messages on this screen from the different other operational facilities that are involved, like the towers calling for release or the TRACON indicating that upon a wind shift there's going to need to be a reduction, a change in configuration and a reduction of the AAR. We also have still TBFM hooked up to this scenario, and so we can continue to show the timelines, the information about the flights that have been scheduled or not scheduled. For example, Air Shuttle 5780 is one of the internal departures. And so now actually if we go back to the messaging display, we can see that Air Shuttle 5780, there's an APREC program essentially in place in this training simulation, and there's also EDCTs. We effectively have this scenario set up so that the flights are being released on EDCTs, even though there is the APREC program. But that being said, that's something that can be adjusted by the scenario. And we can add in some artificial intelligence here to actually have the center TMU make some operationally specific decisions for these releases based on the amount of traffic that is overhead at the particular time that may be interfering with the ability for those flights to be released. And then finally, we could also have multiple participants in the simulation so that the center TMC could participate and make the decisions about which of these flights to actually schedule. So we see here that the TRACON has indicated that when the wind exceeds 22 knots, that it's going to be necessary to switch to a northwest flow. The ground delay program is in and is continuing to operate. We can see different statuses. We see, in fact, that some flights are late with respect to their proposed time or EDCT on the status indication. And we're continuing to move forward through the scenario and see flights as they are beginning to land at DFW. All of this is integrated together and running, again, the same scenario and interactions from either FSM or TBFM that would affect the flow of the flights will appropriately be represented in each of the different systems. Going back to the FSM display, one of the remaining issues that we have not integrated, you can see that we do not keep track of the flights as having actually landed. That's one of the things that we're still working on integrating and correcting, but we wanted to get this demonstration out to you as quickly as we could to show you the capabilities. So we've just switched over into the 1600 hour. In the 1600 hour now, the TRACON has again given a heads up to the other facilities that when the winds exceed 22 knots, that it's going to be necessary to switch to a northwest flow. We are now at 1616, you can see, and in just a couple of seconds we will see that actually occur. We'll get the notice from the TRACON that has happened. There we go, changing northwest flow immediately. Arrival rate now is 48. And remember that what happened was that the FSM program did have a few flights over the 48 that were planned. What's going to end up happening now is we're going to be able to see the result of that as the additional flights flow into the TRACON area. You can see the flights continuing to fly in to the DFW terminal area, and we have a TRACON AI agent that is acting like the facility, the TRACON facility, to make decisions about whether or not it can accommodate that traffic. And in fact, you can see that because of the fact that there were a few too many flights that were planned, the TRACON had to close arrivals for about a 10-minute period and then opened it back up. So we get really a closed loop capability to be able to plan and implement ground delay programs through FSM connected in with this simulation, do all of the steps that would normally be done through the FSM capability, but then also see how it plays out and connects with other elements of the NAS. So that's the demonstration, and we look forward to further discussions.